Good day, students. On this clip, we're going to be going over two examples on how to factor sum and difference of cubes. So before we start, let's go ahead and take a look at some the formulas that will basically guide our factorization process. Okay, so write this down. Formulas. Okay, I'm going to write down the formulas for you, and then I'll tell you a trick that can help you remember these formulas. So for the sum of cubes, the formula is a cubed. I don't need a parenthesis for the unfactorized form. So the formula is a cubed plus b cubed can be factored into a plus b times a squared minus ab plus b squared. Okay, so this is the factored form of the sum of cubes. So the rule for the factorization is you just need to remember that the first sign is the same as the sign in between the two cubes. The second sign is the opposite of the sign between the two cubes, and the last sign is always a plus. Okay, so it's always the same, opposite, and a plus. All right. So what if you wanted to apply the same reasoning to the difference of cubes formula? Well, exactly the same process holds. Okay. So what if we had a cubed minus b cubed? All right, is going to be a minus b. Notice it's the same times a squared, and this will be the opposite plus ab, and this one is always plus. The last sign will be squared. Okay, so these are the formulas for factoring sum and difference of cubes. All right, so just remember the pattern for the sign is that the first sign is always the same. The second sign is always the opposite, and the last sign is always the plus. All right, so that's basically the trick for remembering the sign pattern. Okay, all right, now let's apply these formulas to a problem. The instructions for the examples you're going to do are as follows. Factor the following expressions completely. Okay, all right. Now, the first expression that we're going to factor is the expression for number one is 64 x to the third minus y to the third. Okay, so the first question we're going to ask ourselves is which formula do we use? Do I use the sum formula or the difference formula? We know that the cubes formula applies to this case, so we're going to have to use these two. But before we apply the formula, what if there is a common factor that can be extracted from these two? Well, there isn't any common factor that can be extracted. Well, how do I know? Well, let me show you. I can break these factors down completely or find the prime factor decomposition and see if there's anything that I can extract as the greatest common factor. Okay? So if I wanted to break down 64 I can take out 2 times 32, take out another 2 times 16, take out another 2 times 8, take out another 2 times 4, and then 2 times 2. Okay? So 1, 2, 3, we have 3 pairs of 2, so we can write it out as 2, 1, 2, 1, 2, and then 1, 2, and then 3 x's, x, 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 and then y, y, y. Okay? So you see I decomposed both parts completely, just to inspect to see if there are any common factors, and we can clearly see that there were no common factors as we assumed earlier. Okay? Alright, so I'm going to reassemble it back together. 64x to the third minus y to the third. Now, which formula am I going to use? Well, the sign ultimately determines the right formula to use. If it's a plus in between the two cubes, you use a sum. If it's a minus, you use a difference, okay? This is a minus, so that automatically means we're going to use the difference of cubes formula, which is a cubed minus b cubed equals a minus b, same sign first, times a squared plus the opposite, ab, and then always plus for the last one, b squared. So all I need is just a and b, and then I will plug it into the formula to find out what the factored form is. Okay, so let's figure that out on the side here. To find a, I'll take the cube root of first term, 64x to the third. So what is the cube root of 64x to the third? Well, we can do it mentally by knowing, if you remember that 4 to the third is 64, you can use that fact. So you can have 4x. Or you can look at our decomposition here. We want to find 3 pairs of equivalent magnitude or equal product. Okay, so I can group, since I have 6 numbers that are the same, I can group these two together, and group that 2 together, and I have 4 times 4 times 4. That automatically tells me that the cube root of 64 is 4. Okay? Another way you can do this is by using your calculator. Let me show you how to do this with your calculator. If you want to find the cube root with a calculator, what you do is you enter the number. In this case, the number is 64. And then we're going to raise it to the 1/3 power. Okay? Raising to a fractional power is the same thing as taking a root. If the numerator of the fractional exponent is 1. Alright? So 64 to the 1/3 is, voila, 4. So you can see that the cube root of 64 is 4. The cube root of x to the third is x, because the 3 roots and the 3 power cancel out and initialize each other. Alright, now for the b part, we're going to find the cube root of y to the third. Alright, cube root of y to the third is just y. And we're going to plug in these two into this formula right here. For the sake of consistency, I'm going to rewrite the original problem here as 64x cubed minus y cubed. So if I plug it in, I'll have a minus b, which is 4x minus y. I plugged in 4x for the a and y for the b, times 4x squared plus 4x times y plus y squared. Okay? Now, we need to just simplify this a little bit more, and then that will be our final answer. Okay, so we're going to have 4x minus y times 4x squared. Please be sure to square. This square applies both to the 4 and to the x. Okay, you can't just square one of them. You gotta square both of them. Okay, so if I square 4, I'll have 16. If I square x, I'll have x squared. And then 4x, if you multiply this, you have 4xy, and then equals y squared. Okay, so this is the factored form of 64x to the third minus y to the third. Okay, alright, so there you have it. Now let's try another example. We're going to still the same set of instructions. We want to factor completely. We want to factor the expression. For number 2, we want to factor the expression 2y to the third plus 54. Okay. Now, let's see if I can factor out any form of factor. So I'll break these two terms down completely to their prime factor decomposition. 2 times y times y times y plus, let me break down 54 on the side here using my factor tree. I can take out a 2, 2 goes into 5, 2 times 27. Take out a 3, that's 9. And then take out another 3 and end up with 3. Okay, so it's plus 2 times 3 times 3 times 3. Okay? Alright, now what form of factor can I extract from these decomposed terms? You notice that 2 is common. So I extract the 2, and I'm left with y to the third plus 3 to the third. 3 times 3 times 3 is 27. Okay? Alright, now we're going to shift our attention to this inner piece right here. This is a cube and that's a cube. Since we have a plus, we're going to be using the plus formula, okay? So the plus formula, I'm going to write it underneath here. Basically, we have a to the third plus b to the third is going to be, let's not forget the 2, so let's put the 2 out on the outside, okay? So just keep the 2, and then applying the formula up that we wrote up here, applying the sum formula to this problem, it's going to become a plus b, first sign is always the same as the center sign, times a squared, the next sign is always the opposite, minus ab, and then the last sign is always a plus, so it's b squared, okay? So there you have it. Okay, now let's look for our A and our B. So you can do that on the side here. To find the A, what you do is you take the cube root of the first term on the inside. Okay, so we're taking the cube root of y to the third. Alright, so what's the cube root of y to the third? Is y, because cube root and cube cancel each other out. This is opposite of that. So y. And then b, we look for the cube root of 27. For the cube root of 27, you can see here from 27, if you have the roots, you have two identical roots for 27. 3, 3, 3. So basically the cube root of 27 is 3. Or you can use your calculator. Erase 27 to the 1/3 power. Okay? And the answer is 3 as you can see. Alright, so we have our A and our B, so let's rewrite the problem and then we're going to plug in these values and then simplify as much as we can, alright? So we have 2 times y to the third plus 27. Alright, these are the cubes, so I can align their cube roots. So we have 2 times a plus b is y plus 3 times y squared minus ab is 3y plus b squared is 3 squared. Alright? Alright, let's finish this up. Bring down the 2. 2 times y plus 3 times y squared minus 3y plus 9. There goes the factored form of the original problem. 2y to the third plus 54. Okay? So, there goes your final answer. Alright. So thanks so much for taking the time to watch this video. Please feel free to subscribe to this channel so you can get updates to cool videos such as this. Also, you can share this content with your friends via Facebook or Twitter. More videos can be found on mycodeshop.com. Thanks again and have a wonderful day.